question is, let u, which is equal to minus 1, 2, 3, v, which is equal to 2, 1, minus 2, and w, which is equal to 0, minus 3, 1, be vectors in R3. Find u dot v cross w, w dot u cross v, and v dot w cross u. What do you notice? Well, if they've asked me what to notice, there must be something to notice. I suspect they're all the same, or possibly maybe negatives of one another, or maybe they add up to 0. I can't really tell, of course, until I do it, so let's start. V cross W is equal to, well, according to the notes, it's this thing. IJK, and then I put down V, which is 2, 1, minus 2, and then I put down W, which is 0, minus 3, 1. Okay, so it's this 3 by 3 determinant, which means that I'm actually going to do this. So I do I times the determinant of the bit that I get when I remove the row and column that I is in. So I'm going to get 1 minus 2 minus 3, 1 minus j times 2, 1 minus this bit. And it is minus j, that's important. It's not plus j, plus k times 2, 1, 0, minus 3. Okay, so I have 1 times 1, which is 1, minus 2 times minus 3, which is 6, minus j times 2 times 1, minus 0 times minus 2, plus k times 2 times minus 3, minus 0 times 1. So I get I times minus 5 plus j times minus 2, so I brought that minus in with the 2, plus k times minus 6. Now this I, j and k are convenient placeholders for the coordinates of the vector that I get from v cross w. So remember that the cross product takes two vectors and produces a new vector. So I get minus 5, minus 2, minus 6. That's my vector. The I is the place for the x coordinate, the j is the place for the y coordinate, the k is the place for the z coordinate. Technically I is actually the vector 1, 0, 0, and j is the vector 0, 1, 0, and k is the vector 0, 0, 1. So if I actually do that linear combination of those three vectors, then this is the vector I produce. Okay, so I wanted to do u dot this vector, so u dot v cross w. Well, u is minus 1, 2, 3, and v cross w is minus 5, minus 2, minus 6. So I get minus 1 times minus 5, which is 5, 2 times minus 2, which is minus 4, and 3 times minus 6, which is minus 18. So I get minus 17. Alright, let's do the next one. U cross V is, let's see, I, j, k. U is minus 1, 2, 3. V is 2, 1, minus 2. So I get I times 2 times minus 2, which is minus 4, minus 1 times 3. Minus j times minus 1 times minus 2, which would be 2, minus 2 times 3, plus k times minus 1 times 1, which is minus 1, minus 2 times 2, which is 4. So that would be minus 7i So 2 minus 6 is minus 4, and minus minus 4 is plus 4, so plus 4j minus 5k. So that's the vector minus 7, 4, minus 5. And I want to do w dot u cross v, which is, well, what's w? W is 0, minus 3, 1, dot u cross v, which is minus 7, 4, minus 5. So I get 0 times minus 7, plus minus 3 times 4, which is minus 12, plus 1 times minus 5. So that's minus 17 as well. Okay, so I'm suspecting that the other one will come out to minus 17 as well. Let's figure that one out. Alright, so now we want w cross u is equal to, so I, j, k, w is 0, minus 3, 1, minus 1, 2, 3. So I get I times, minus 3 times 3 is minus 9, 2 times 1 is 2, so minus 9 minus 2, minus j times, let's see, 0 times 3 is 0, minus 1 times 1, plus k times 0 times 2 is 2, minus 1 times minus 3 is 3. So I've got minus 11i, minus 1, so that's minus 1j, minus 3k. So that would be minus 11, minus 1, minus 3. Right, v dot w cross u is, alright, v is 2, 1, minus 2 dot minus 11, minus 1, minus 3. So we get 2 times minus 11, which is minus 22, plus 1 times minus 1, which is minus 1, plus minus 2 times minus 3, which is 6. So we get minus 23 plus 6, which again is minus 17. So what I notice is, so now what did I actually figure out? U dot v cross w is equal to w dot u cross v, which is equal to v dot w cross u. So they're all the same. Now, the question asked me to find those three numbers and notice something, which I've done, so I've actually finished the question. But, like a really good mathematician, I wonder if this always happens, because sometimes you get asked questions in order to teach you something. So, I think I'm just going to do a little description of why this always happens by letting u and v and w be any vectors. So let me start a new page. Okay, so let u be a, b, c, and v be d, e, f, and w be g, h, I. Okay, then v cross w is I, j, k, d, e, f, g, h, I. Alright, well that's I times this determinant minus j times this determinant plus k times this determinant which is this vector E, F, H, I. minus dfgi degh. Alright, and u dot v cross w is a, b, c dot this vector. I can't be bothered writing all of that again. So that would be a of e, f, h, I minus b of d, f, g, I plus c of d, e, g, h. Hey, but that's the same as what I had up before, but I've got a instead of I and b instead of j and c instead of k. So in fact, it's the determinant of the 3 by 3 matrix. That 3 by 3 matrix. This is where it comes from, because if I rearranged u, v and w in that expression to get, say, w dot u cross v, then that would be rearranging the rows of that matrix and then doing the determinant. And I know, and you'll know soon enough, that when you rearrange the rows of a matrix, all it does to the determinant is multiply it by plus or minus 1. And so what we've got is ways of rearranging that matrix to not change the determinant, to multiply it by plus 1 instead of minus 1. And you'll learn about that a bit later, so that's why it happens.